folder broke.
You thought we were taking a test today, Mr. Ward?
No. So, all right. Hey, real quick. Homework due today. That's your page 434, 447. Hey, homework's due today. Practice guide due tomorrow. Test is tomorrow on Wednesday if you need the second day, which I almost expect. Maths testing will be this Thursday, Friday. Seniors in here, you will not be doing maths testing. You'll just be working on your practice semester test. That would be a good day that I'll probably, on those days, I'll move you to a certain corner by the board. And I'll have just the seniors and I'll go through any review questions you guys have. Those are good days. Everyone else that's math testing, I'll push you to the back of the room. That way they have time.
Oh, math testing is tomorrow?
No, math testing is Thursday, Friday. Way to pay attention. Okay? Alright, book covers. We're checking book covers Wednesday this week. Wednesday is book cover day. That's seniors as well. I need to make sure that seniors still have your books. They're still covered. Because if you're missing a book, I have to put that on your late charge that you have to pay. I think we have to put those on the list by this Friday if you owe me any money for those seniors. Okay? Better go quick. Okay, question.
I completed my assignment.
After this chapter.
You're in front of the camera. Yeah. So.
There will be no test over that chapter.
No, but next chapter, what are we doing for next chapter? Since like
Chapter, we mix a little bit of chapter 6, 7, and a little bit of chapter like
17.
13.
Are we going to be finished in time for the seniors to take a test on that, or is it just us?
Just you guys take that next test.
I like that.
So.
It's always
Alright.
Mr. Ward, how many credit hours is a full-time college student? Is it 16?
12.
Oh, jeez.
12 is full. Most kids go with about 15, 16, somewhere in that range.
How many did you take?
18,
27.
21,
Yeah.
and then I took some
35.
smaller ones because I was teaching a lot. I was another, like,
Tori's at
Weird
39 right now.
I would not recommend taking over 18. It was way too heavy.
She's gonna take, what is it, 17 next
That's a
year?
lot. It's a lot. So, all right. Okay. Hey, on your practice guides. Okay. Hey, on your practice guides. We already went through on Friday. We went through how to type this in your calculator. We went through how to graph this by hand very, very quickly. If this number is above 1, the graph slopes up. If this fraction here is less than 1, it slopes down from the left side.
So greater than 1, it's
Okay, it goes up. It's exponential graph, what normal people think. I'm just testing whether you understand like what an exponential is versus decay. Can you look at the problem and instantly know what it should look like right away? Okay, and I'll try to make sure that these videos and stuff, even today, like right after school, I'm going to try to post today's video. I'll even attach Friday's video below it so you don't have to go back to Friday's. You can just look on today's if you want. Because I know like Bradley was gone, so it's probably convenient. You can just look at today's and just kind of see all the videos and stuff. Okay, number 3, we talked about how to change this to exponential. You're not solving that. 4, we're changing that to logarithmic. We're not solving that. 5, you're simplifying without a calculator. You are trying to get down to a single digit on that one. It could be negative, positive, it could be a fraction. 6, 7, same thing. 8, same thing. These are all the rules of like how to simplify logarithms. 9 is the one where we finished yesterday on Friday, where we expanded this out as far as we could. Today, we're going to start here and work our way to the end.
Mr. Ward, you know what would be cool?
What?
If you, so you know how number 9, you have to expand it.
Yeah?
If you made that the start to number 10, so then we condensed it back to where it started on number 9.
No.
That would make a lot of sense. It'd be good.
That would be
No.
difficult.
That way we know we did it right if we get the same answer.
We're capable of figuring out.
No. Alright, moving on. Okay, number 10. Alright, since all this is in a parenthesis, you can combine all of this down to a single logarithm, not multiple. This is where people get it wrong on the homework. And you can move this power to the top of it all, because this will eventually become 1 logarithm. So everything will be to the 1/3, so we're going to be in a radical. That's what the 1/3 is. Okay, so combining this down, this 2 goes to the top of this one. It's the natural log of x plus 5 squared. Okay, that whole thing is squared. Now, with these in the back, they're being subtracted. Subtraction means they're on the bottom of a fraction. This is where some people got it wrong in the homework. It technically wasn't like incorrect, but it was the way they wrote it isn't what I was looking for. I'm looking for 1 logarithm.
Why can't we write just ln over ln and cancel them?
No. So, ln, 1 single logarithm that has everything behind it, is what this thing is representing, not multiple logarithms top and bottom. Okay? So,
Let's just divide by x.
so this thing is, this is the top, these are the bottom, since they all use the same natural log, the items that are being subtracted are on the bottom of this item. And this is where some people get wrong, where they try to put things on the bottom of a bottom, and they try to make like a 3-tiered complex fraction. It's technically correct, but that's not what I'm looking for. The one thing that I know is definitely wrong is when somebody writes this. Don't write this, by the way, this part. That's wrong, and people are doing that in the homework.
But it's so wrong.
Not how you do that problem. It is a single logarithm out front. Now the problem is, this is all still to the 1/3 power, because you can move things to the top of the power. And if it's a 1/3, if that is a radical, it's a third root, right? Because that's what a 1/3 means.
All up under.
With x plus 5 squared, the x and the x squared minus 4 on the bottom, and then the natural log is out front of it all. Not inside of it, it's out front of it. Okay, questions with how you combine it back down. I tried to pick a problem where everything was mixed together. The only thing I really don't have here
That's all.
is I don't have things where they're being added, like natural logs being added. Now, again, this could be a natural log, it could be a normal logarithm, but if they had something like this, if you're trying to combine this down, this is one single logarithm, and since it's being added, these are being multiplied together like this. Okay, it's a single logarithm. Adding means to multiply the two items. Subtraction means to be divided. If they have powers out front, you can put them up on the top. Okay, questions, comments?
How should we?
Perfect. Moving on here.
Math.
Which word do you like that word?
Wait, is that the final answer?
You know how he feels about that word?
No?
Math.
Okay, moving. Moving to the next part here. All right, what do we got? Number 11. Okay, these we have to solve. Now, you can do it with exponentials, you can do it with logarithms. Like on this one, I will have to use a logarithm because on this one, the x is up in the power. So I know that I'm going to have to use a logarithm at some point to drop the power out so we can solve it. Down here, same thing. Now, it matters if you're going to do a natural log versus a normal logarithm. On number 11, I'll use a natural log because there's an e. On 12, I'll use a normal logarithm because there's no e on that problem. It really doesn't matter. The calculator will still give you the same answer if you use a log or a natural log. It's just that there is a difference in like why you use it. So let's talk about number 10 here. So on this one, I'm going to divide the 4 over first to get the e to the 7x by itself. And on this side, this is 10,273 all over 4. I'm just going to leave this as an exact answer for right now, and then we can type it in the calculator in a minute. Again, if you're doing the decimal, you just divide these first. Get the weird number. It's going to be like 2,000 something.
2,568.
There you go. All right. And now the next thing is to drop the power out. This is where you have to take the logarithm or natural log of both sides. That way you can drop powers out. So on this one, I'm doing the natural log because they have an e on the one side. So when you do that, that's why the 7x can drop out front because it's called the power rule, right? The 7x can go out front, the natural log of e, the natural log of the 2,000, whatever it is, but I'll just write 10,273 over 4, which if you write the 2,000, you're fine, okay? I'll have probably both answers. And now, the natural log of e,
Cancels.
yeah, this part is the number 1. Now, how I know that? Natural log of e means log base e of e. That's what natural log means. And you're trying to figure out what power you put on an e to make this e, you put a 1. So that's why this whole thing is a 1, it goes away. And the last step, divide by 7. So your final answer, x equals the natural log of the 10,273 over 4. And whatever this answer is, you divide the whole thing, that thing, by 7. And again, that 7 is not in the logarithm, it's on the bottom of everything. So you gotta find the logarithm first, and then divide the whole
What did you
thing.
get for the answer? I got 1 point.
Sounds about right.
1.1.
Yeah, that sounds about right.
2.14.
Could be wrong.
Apple pie.
Okay, now, I'm not gonna solve out number 12 for you, but I will start it. I'm gonna start it, okay? That way, it's gonna look exactly like number 11, okay? All right, on this one, you notice that they have the same bases.
Yes.
Okay, so if they have the same bases, you're allowed to add these together. If they're being multiplied, the rule for algebra 2 was you can add the powers together. if they have the same bases. So you can add the powers together. And so in this one, I'm gonna add, so I get 3 to the 2x plus 2. If you actually add the powers together correctly. And now you're gonna do the exact same thing you just did in the last problem, where you take the logarithm or natural log of both sides, it really doesn't matter, but I just take the log, drop the power up front, and divide, and you can solve it out. Okay, now the only problem is, the only difference between this problem is when you take the log of both sides, and you drop the power up front, like what I did up here. The natural log, or log, when you do the log of 3, that won't just go away.
You divide by it.
You have to divide by it. It has to go to the other side, because the log of base 3 doesn't make 1, right? So whatever that is, you have to divide by that number over first, and then you can, whatever's out front with the x, you can do the normal math like algebra 1.
So it's like 81 divided by log 3.
Yeah. It would actually be log of 81, because you have to take a log of both sides.
That's what he said.
So.
You can't just change 81 to the fourth power.
What?
Can you change 81 to the 3 to the fourth and then cancel the 3?
Oh, yeah, you can do it that way too. Yeah, so if you want to do like old school, so if you want to do like, because I said there's like multiple ways of doing this, yeah. You could just change this 81 to 3 to what, 4th? So 3 to the 4th power, and then yeah, absolutely. Now you can just set like these powers equal to each other. So that's a different way to do it. So you have like, every problem has multiple ways of doing that. It's actually really clever.
It's clever, Justy.
But
I got 4.
But the idea is that like if you can't see that right away, you could just do the logarithm of both sides and do the old-fashioned way. So like noticing that it was 3 to the 4th, that's really clever, because now you don't have to do that whole thing where you take the log of both sides. You can just set the powers equal and solve it. It's no algebra 1. Okay.
Yeah.
All right. Questions, comments, concerns. That's probably actually the easiest way, but I'm trying to tell you, like, I don't know if that problem on the test will work out pretty. So you might want to practice using logarithms and see if it does give you the 2 or whatever it's going to be. Or 1, sorry, 1. Okay, we're good? All right, let's move on. All right, next problem, okay? All right, these, we have to find the logarithm of each equation, simplify them, and then try to solve for x. Now, I will give you guys the option right now, because I'm gonna do one of these problems versus the other.
14.
So you want 14 or 13?
14.
Okay, hint on 13 before I just move to 14. You want to subtract this over first,
You could just show us how.
because you want to leave the 2 by itself. It didn't have a logarithm on it. So you want to move this over, and then you're going to do the same step I'm about to do over here.
Yes, sir.
Okay? On this part with this 2, you want to put the 2 up here on the top of this
Square it.
one. The 2 goes to the top of this x plus 4.
What?
Make it squared. Okay. All right, I'm going to show you number 14, because 14 is actually probably the harder problem out of the 2. All right, so 14, and again, some of these problems could have no solutions, so be careful of that. They could have multiple solutions, because you'll have to fall back to algebra 2 at some point.
You have to reject the values that aren't in the domain.
Yeah, exactly. Okay. All right, good choice of words on that one. All right.
It's almost
on
like
this.
you said it yourself.
Okay, yeah, it's almost like I typed it on there or something. All right.
Almost, but not.
Log base 2, x minus 1 over x plus 3. Now why I'm doing that is because these are 2 logarithms that have the same bases and they're being subtracted, so I can make it 1 logarithm with division. Okay, we get to here. And again, why I don't need to drag logs across the equal sign is because I don't have just one side doesn't have just a plain number, so I don't need to do that. So now on this one, the difference between 13 and 14, 13, once you get the logarithms to one side and you get it to one logarithm like this, and the other side has a 2, you have to do like a circle method to take it back to exponential, where you go like this power to this item equals this thing. But mine I don't have to. Since I have logs on both sides, you can just cancel them out. That's a rule of logarithms. If there are logs on both sides that are correct, that you haven't combined down to single logs, you can cancel them out. So what I'm left with is this, and this is a problem that we did in Algebra 1, where you cross multiply diagonally, where you multiply these diagonally, you multiply these diagonally, and you set them equal to each other. It's called a proportion range. Yeah, kind of. Where you take x times x minus 1, you take the 1 times the x plus 3, because that's how you solve proportions, you cross multiply correctly. And then you just solve with algebra 2. So this turns out to be x squared minus 1x, x squared minus 1x on the left. On the right side, I have 1x plus 3. We'll solve. This looks like it's going to turn out to be an algebra 2 problem where I have to move everything over to the one side. So let's subtract this over, so it becomes a quadratic, a trinomial. So this is going to subtract negative 2x, subtract the 3 over, this equals 0. And now you can just factor that thing apart and figure out that there's two potential answers. Which one of them will probably cancel out? All right.
How does it cancel out?
We'll talk about that. How do you know like which answers work? Because they'll make the logarithms negative and you can't use that. All right, so in this part here, it's going to be x plus minus, probably what, 3 and 1?
Yeah.
Yes.
To make the negative 2 in the middle. So it looks like one of the answers will be a negative 1. That's probably the number we'll throw away here in a minute. Or one of the answers will be positive 3. Because those are the two numbers that can make those parentheses zeros. The negative 1 won't work. Because if I plug a negative 1 in here, they'll make this thing negative and you can't have a negative. I don't care if you square it or whatnot or whatever you're going to do to it. It doesn't matter. You can't have a logarithm of a negative number. It doesn't work that way. So the negative 1 is probably being thrown out. And so it probably has one answer and you have to kind of check to see, but it's probably the 3.
So should we just put a 3 down?
Yeah. Now on yours, remember, when you get this down to a single logarithm for you guys, you know, whatever this thing is going to be, blah, 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 whatever that is, equals 2, okay? Whatever yours is on 13, since you don't have a logarithm on that side, you can't just cancel them out. You'll have to go back to circle method, where it's 2 to the second power, 2 to this power equals this whole mess. Okay, whatever that is, blah, 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 blah. Okay, whatever that thing is. And then you can solve on your 13.
Mr. Ward, I think you did easy.
Wait, why can't you just put the log 3 to whatever 9, make that equal 2?
Could you do the top
Yeah,
one
why don't you do
real quick?
that?
And
Look at
then,
look at
Oh, yeah,
and then have it 4,
Yeah,
like on
you can
one
do that.
side, and then divide by 2.
Mr. Ward, you always show us
Can I
the
do it
difficult
that
way to
You
do
do
this.
that.
Mr. Ward, how was your weekend? Matt.
We
Alright.
can take it.
Why was
That's
it
good.
just, why was
Rouse,
it
you're all about seeing the shortcuts.
why was it all
Wait,
about?
but now, what do you do? So I did that, but then you get to log 3, x plus 4 equals 2. How do you get?
Do it,
Oh,
circle
the
method.
circle.
Yeah.
Then, yeah, circle this, that power equals this thing, and solve.
Oh,
So
God.
what's the answer to the 13?
It's late.
What will that be?
5.
2,
It's a horse bar.
9, yeah, 5.
X equals 5?
X equals 5? Is that what you said? Good call.
Alright, moving on. And it looks like 5 should work because if you plug them in, it won't cause any problems. Alright, okay, alright, moving on. 15.
18.
16.
Okay, alright.
17.
15, this is, hey, this problem is 2 and 1. You have to figure out which one's the better investment. Again, you probably have seen these in your homework, or at least you should have if you've been working on it. $12,000 investment, and they'll tell you if they're compounding continuously or compounding monthly or whatnot. This is the compound of a certain time frame, like monthly or quarterly or semi-annually. This one is the continuous. So on this problem, you will be using both to compare, like, if you're just typing in your calculator and figuring out which one. I don't want you just to circle the right one. Like, oh, it's monthly, and you circle it and move on. I actually want to see the numbers, like why it's this one. And I want to see like you comparing them. Nothing's worse than, you know, people doing the test and they're like, okay, it's gonna be the monthly, it's just 7%, it's monthly. But you have no data backing you up because compounding continuously, those are such close percents, it could easily be the other one.
Wait, question.
So there's a breaking point. So you do have to show both and actually like circle the one that works, like circle all math that proves why one works. Okay, you're trying to figure out which one's the better
We need to
investment.
do it in monthly.
If you circle it without showing work and you get it right, how many points do you lose?
Whatever the work is. So let's say this problem's worth 6 points. Maybe it's like 3 lines apiece plus the answer, so 7 points total. Maybe.
So you
If you're
get
on
You
back
miss,
line,
you probably
you
miss, you know, the 3 points if you didn't show any work for that one
So you
side.
get 1 out of 7.
What if you have a background
Technically,
in
you showed no work,
finance?
yeah, 1 out of 7.
All right.
So, question.
What does compound continuously mean?
That means this. It's where they're compounding it
No, I understand
every second. It's not just compounding it like in a certain time period, it's compounding it every millisecond of the day. So every second of the day they're calculating like it's growing slowly by slowly every minute or every second. Like there's some small penny that they're adding to the account.
It's less than a penny.
Okay, it's less than a penny per
If we were making a penny a second, that'd be a good day.
Yeah, it'd be a really good day.
Because guess what?
You'd be like a millionaire in a
7, 10, 10.
matter of
Shut up, you
week.
know, 3,600
Alright.
seconds in an hour.
Okay. Okay, hey, we good?
4 times 7.
Alright,
Please let me figure
So-
that out.
52.
alright. let's, now, is there a certain one you want me to do so you can see
It
it?
would make $865.
No? Okay, I'm gonna move on. If you guys are comfortable with like plugging in the numbers, remember, P is principal, R is the rate, and that has to be written as a decimal. Don't type in 7 here, put 0.07. The N is how many times they compound it, so it could be like 12 or 2.
Wait, is that in
This
months?
is how much.
Months.
Three
Okay, so over
No,
3
the
years, so
T,
monthly.
the T here, T is in years.
So
The
3
N is how many times they compound it. So this could be any time frame. It could be twice, could be monthly, so 12.
So what does
So-
it say? So it says.
They say compounded monthly,
Seconds.
so the idea is that the N's will be 12s here on that. The T will be what, 3 years? So the T will be 3 there. Okay. R is gonna be 0.07 on that one. The second one, it'll be 3 for the T, there'll be a 0.0685 up here for the R. Because you have to write that percent as a number, like as a decimal.
And is the T also in years?
So we want the one with the higher.
Yeah, you want one that's gonna give you the better number in a calculator, and I wanna see
I didn't
both
know if
work.
it was bank
Okay.
statement and you
Yeah.
had to pay this much.
Alright, moving on.
Are we gonna do this one? Oh,
Okay, we're going on to 16. This is one that you should have seen on the pop quiz we took last week. It wasn't even a pop quiz, it was just like a, it wasn't even a quiz, it was just kind of a 5-minute check.
A formative
Exit.
assessment.
Exit ticket, that's the best way to put it. So,
Per se.
alright, per se. Meh.
Because that's how his
Alright.
weekend was. It was meh.
Okay,
He
hey,
did too much work to enjoy it.
okay, I do want to talk about this one. So, I'll do the first half and I'll let you finish it up. So, first half, you were doing so many millions of people by 2050,
It's like a whole
and it's growing.
Like 3 guys.
So it's growing to 10 million by 2050. So here's the idea. So in my formula is actually printed here. So the amount of people, the initial amount of people, the rate that it's growing by, and then the time in years or whatever it's going to be in. So my initial amount of people is 6.04 million people. Right? I don't even have to put millions. I can just put the 6.04. I need to grow to 10 million in 50 years. So that's how I'm getting the 50 years to put up here. It's because they started in the year 2000 and it went to the year 2050. So it's going 50 years. And then what we'll do is we'll solve. We'll divide this number over. So 10 divided by whatever 6.04 is. And then we have to get the power to drop out front. So to drop the power, it's like what we did earlier on that first problem, bless you. We'll take the natural log of both sides to drop the powers out. So when you do this, this will be the natural log of the 10 divided by 6.04. We take the natural log of the other side, dropping the 50k out front, like that. So this power dropped out front here, to be the 50k out front. And then the natural log of e will go away, because the natural log of e is 1, and you can divide by 50. Now, what I would actually recommend that you do, figure out this answer first on a calculator, then take it divided by 50. So, because some calculators, they just require that you actually type it in like parts at a time.
Oh, like the Casio because it's stupid.
Okay, no. So,
Yeah.
alright. So, natural log,
Casio sucks.
10 divided by 6.04, close that parenthesis. That answer is like 0.5, whatever it is. Divide that by 50,
5, whatever.
and the number turns out to be 0.01008. So it's like a 1% growth. Really slow. Okay? Now, why we're going to use that is because the second part of the question says, find what year Israeli population will be in, what year it will be to be populated to 9 million people. Well, here's the idea. We started
50 years.
with 0.604.
6
I want to end with, what is it, 9 mil? And my growth rate is 0.1%, and I want to know time. Well, here's the thing. I can tell you, it's got to be less than 50 years. It's got to be less than 50 years.
Of course.
Because it took 50 years to get to 10 million people, so to get to 9 million people should be less time. Okay? So it's got to be between 2000 and 2050. It's got to be somewhere in between there. And where I'm getting these numbers from, I'm using my rate in the actual problem.
It's
That's
like
the part you're doing.
what if you calculate the rate wrong, but calculate the years right off of your incorrect rate?
I will count that right. I'll count probably a point off for getting the wrong percent. But I will give you points if you do the rest of the problem correctly. Because I can easily see somebody types it in wrong, gets the wrong number, but then they finish out the problem. If you at least finish out the problem, you did everything correct, I'll at least give you points there. Because it's like, you know what to do, it's just you got a wrong number, and that shouldn't impact your grade on that. Okay, so you might get 1 point wrong for just, maybe you accidentally divided by 50 and you didn't close these parentheses, so it calculated 10 divided by 6 divided by 50 and then took the natural log of it. So just gotta make sure parentheses are a big thing to close.
39 years.
Okay, all right, last problem, or I should say last 2 problems, I should say. These are based on growth, and again, these were all these problems are on that 5-minute check that we did the other day. Okay, the formulas are all printed up here. So like one of the questions I had on that 5-minute check was, Ward, hey, how do you know that formula for like the infection rates? They always print it for you. They just make up a number, they print it, and they go from there.
Question,
Okay.
are they like accurate? Like are these
Nah,
real
I think
studies?
these are just
They
made up.
just
I
make
just pulled them
them
out of the book.
That's way less fun though.
The problem is like
My
some of the problems in the book, they put like little asterisks next to them, and in those side notes they say this is data collected from USA Today and Times, and
Yeah,
like
so are those,
so those would be accurate.
are all of
this-
them that way or just?
No, certain problems that have, they have asterisks next
So
to
like,
them.
is this not actually the half-life of whatever we're talking about here?
Thorium. I didn't even know thorium's real.
Chromium?
I don't know
No, that's not.
I don't know my
It is.
table.
It is real.
Your periodic table.
Yeah. All right. Let's go to decay. Now on this problem, it wants to go to 3 decimal places. This is the exact same problem, the one we just did. This one's going to have a half-life, so we know that the rate will be negative. Like the last one, the population was growing, so it was positive. This one's decaying over time. So it took thorium 7,000 years to go to half-life. So this is the part, like on this first part of the sentence, you get to make up any amount of like substance you want. I always say like 100 grams, and you're going down to 50.
Can you
Go-
just write 0.5 and
Go,
not
yeah,
half
just,
to-
I would go, or like, go 2 and 1. You're just going in half, yeah, but you can put half into those in a minute. The rate is the thing I don't know, but it's taken me 7,340 years to get there. Okay, that's my time in years. Where I'm coming up with these numbers are numbers you can make up because I'm going to half-life, 50% of it. So you can move that number over to the other side. If you want to go to 20%, fine, just put a 20 over here. That's how you do 20% life instead of half-life. Okay? But I'm going 50 and 100 because I just know that's perfect half. Divide this over, and just like Reese was saying, this turns out to be half over here. Take the natural log of both sides to drop that power out front.
I went 0.5.
Natural log of half or 0.5. That's the 7340K. Natural log E. That goes away. Divided by the 7,340. This will be a negative number because it is going half-life. So my K should be negative. 0 point something.
0.000094.
How many zeros?
4.
2, 3, 4, 9.
4.
4, 4. Wow, that's a really small rate.
Wow.
So decay is really slow. Okay, is that right?
4 whole.
Yes.
Yeah, it is.
Okay.
That was one of our homework problems.
Yeah, okay. And the idea is that taking that number, and now we're going to use that rate, and now we go to 20%. So your second half of this question, now knowing that, now you're going to go and you're going to finish out this problem by doing this. You're going to go,
That's close to 7,000.
you're going to go, if you need to get down to 20% life, and you know that your rate is negative 0.0000944t, it wants to know the time it will take you to get there. And I'm going to 20% life.
Wow.
So I went 100, and I went to 20 on the other side, but I'm using the rate, and that rate is negative because I'm going down.
We'll divide by 100.
Yeah, divided by 100, you get the 0.2 on the other side. Take the natural log of both sides, drop it up front, do your whole thing. Now,
17,000.
last problem. Number 18 is by far the easiest problem if you know how to type it in the calculator. Yep. So the first part. What does the model function for the year 2000? So the year 2000, so this idea is that you have to calculate the number of years from 1947 up to the year 2000. Was that 51 years, something like
I think
that?
it's 71.
So,
9.
It's 51 years. It's 51. It's
I
51.
did the other 4.
Mr. Ward, you second guessed yourself really bad right there.
I thought I just read it wrong.
Oh.
So, all right, 51 years, you plug that into X, because X is in terms of years. And then once you have it typed in, you can just type this number and it will tell you what infection rate is for that, or growth model for this world population. So this is world population. So the top number on this world population is what the max life that scientists have come up with that we can sustain on this planet before everything starts to go downhill. So it's 11 billion people.
Have they calculated how long it'll take for our world to reach there?
That's what you can
That's what the-
actually.
That's what the question is.
That's what the question's actually figuring out, kind of a thing. So if you
But it
go,
says one of those.
Breeze, do you know,
so
It
well,
says reach 7 billion.
yeah, 7 billion.
Mr.
Well, you
Ward.
can type in 11. You can figure out that number.
Mr. Ward, do you know when the world's population reached 7 billion people?
I think we're already past that.
Yeah, when?
2013.
When was it?
2013.
2013.
Armis is.
2011.
October 31st.
Oh, they went.
Okay. All right. Now, hey,
All
Okay.
7 billion.
world
together.
population to reach 7 billion. To do this problem, you have to do this. You have to put the 7 bill on this side. 1 plus, what is that? 1 plus 3.81 to e to the negative 0.027x. All right, whatever it is. All right, now to do this problem, you have to take this part here. We talked about this in class. You have to multiply this over to the 7 because you want to get the fraction to go away. That way you can solve for x. Once you have that, you can distribute the 7 through the problem, through that parenthesis when you move it over, because there will be a parenthesis over there. And then you can just do normal algebra 1 to solve it. It will turn out to be a lot like problem number, or the one we did up above, where you have to like actually distribute and actually solve. But the idea is, on this problem, you have to take the natural log of both sides, to the power out, and actually solve. The solving part will be a lot like these.
Or so you multiply by the bottom?
So yeah, you'll multiply the bottom over, distribute the 7 through it, and then just solve for x like you normally would. You'll have to subtract numbers, divide, all that good stuff. It shouldn't take very long. If you guys need me to work through that, just so you can see the first part of it,
Yeah. You should
we can, but.
Nah, let's not. Shut up.
Will you distribute
I
it
need
for
help.
us?
Yeah,
So, okay, so if I distribute, so I'm just gonna take the 7 times that parentheses. So I'll get 7 plus, 7 times that is 7, 6, carry a 5, 26.67 e to the negative 0.027x equals 11.82.
Why can't you get like flip
right
on?
on.
I can multiply in my head pretty well.
That's
So,
insane.
You can't add
No.
though.
so I can't
What's
add-
38 plus 16?
Can't we just like flip
What?
thing where you put that on that side and the seven on
Breeze,
the
I
bottom?
defeated Mr.
Yeah,
Ward.
you can just switch on. Yeah, you can do that. Because that's technically what I'm going to be doing. That eventually I'll be doing the same math, but on this one you'd subtract the 7 across, or if you're listening to Josh, she has her own way of doing it.
Mr.
She
Ward,
has shortcuts all
I have an
day.
easy one for you.
And then divide by that, and then take the natural log of both sides.
Mr. Ward, what is 1 plus 12? What's 20 plus 86?
106.
Oh, you're good.
All right, we're
Even
in
a
the
curveball.
Good even number.
Okay, so
Start
what's
with
17 plus, what's 17 plus 18?
6.
35.
I can't add this. So. I can multiply in my head, I can divide in my head, I can't do that.
You subtract it.
Why don't you attack your weak